Good morning and welcome to the International Space Station Flight Control Room here in the Mission Control Center. We have with us here Kenny Todd, who is the Ops Integration Manager for the Space Station program, and he's going to give us an update on the incident with the cooling loop on board the space station yesterday. Tell us a little bit about what happened and what the team here on the ground has been doing to get it fixed.
Let's see. Good morning. Yesterday, well, as most people know, we have two external thermal control loops on the space station. The loads that are on space station, the electrical loads, the heat loads, all the energy and the heat that gets developed as those ORUs operate gets dissipated through these external thermal control loops. And we had yesterday a situation where one of those loops powered down. The reason behind that is all still in work. At this point, the system it's up and running, but there's a key component of the system called the flow control valve that does not at this time appear to be working properly. That particular valve, the role of it is to help regulate the temperature of the ammonia in that loop. It's very critical that we maintain the temperature in that loop so that when that ammonia is reintroduced into the heat exchanger that's on the node 2, that the water that's also flowing through that heat exchanger does not freeze. And so anyway, that's a very delicate balance that we have to operate in. And so we have systems and checks and balances in place so that if the temperature in that loop gets too cold, that the loop itself will shut down, and that's what happened yesterday. And so once the loop was repowered, this flow control valve that helps to regulate that temperature, it became apparent as the team was recovering the loop that it wasn't quite functioning the way we thought, and we weren't getting the same level of temperature response that we were expecting. So for that reason, we chose to leave the system not integrated, and by doing so, that forced us to have to take some of the loads off of the node 2, some of the heat loads, which caused us to power down some boxes, some ORUs, some systems that are considered non-critical.
ORUs, that stands for orbital replacement
orbital
units.
replacement unit, correct. And so we took those boxes down. Again, we haven't lost any primary functionality. There is some redundancy that we're down right now, but again, that's not something that I would call critical to day-to-day station operations. Should we have a failure in one of those areas, obviously we would want the redundant unit up. So this is a position we don't want to be in long term. And so the team is continuing to work through the fault tree of what might be going on with this particular flow control valve, and that work is ongoing as we speak. And so, in the meanwhile, we've got a good stable configuration. The crew's in good shape. No issues there. They're continuing to go about their day-to-day activities. Where we can, we're giving them good science. And all the science that we've collected up to this point is not at risk, so we're in good shape there. As far as our forward plan, we do have an orbital launch that's coming up. And this morning at the mission management team meeting, we were doing our readiness for that particular launch, which was to occur next week on the 18th. And at this point, I deferred the go/no-go for that particular launch until we get a little more information on this particular issue. As I said earlier, there's some issues with redundancy right now, that when you get into a situation where you need to bring up another visiting vehicle, you want to make sure that you're in the best possible position you can be in. And so for that reason, we have what we call launch commit criteria, and that criteria is in place to ensure that the systems are at the right level of redundancy and operating properly. And at this point, based on that criteria, there are a few of those commit criteria that we cannot meet. And so we understand which ones those are, and we're looking at options for things we might do to recover that redundancy. But obviously our primary focus at this point is trying to recover this loop. And when we recover this loop, we can power those orbital replacement units on and get back into a better configuration to support that launch.
So I'm sorry, you said the go no go has been deferred. So at this point, the launch has not been given the go ahead to launch, but it also hasn't been postponed yet. Is that
Correct.
correct?
As whenever we build a launch time frame, we usually build it in Windows, and so or this orbital launch is like all others. We have a series of dates that we can go on, and right now we could go all the way up until the 21st, possibly the 22nd, but for sure we can go up to the 21st, and so we've got 3 or 4 days in a launch window that we can decide to. Day by day, if things look like we're starting to mature an option to recover this particular loop, we can slide a day here and there to try to let those ideas and those thoughts and those procedures mature that get us there. So at this point, there isn't any harm in pushing that go no go. This is clearly an issue that we need to try to deal with in its entirety before we commit to the launch orbital 1. So we're committed to doing that, and I think giving the team an extra day or so to think through what ways we might recover enough of the functionality to get comfortable with the launches is going to be our best course of action over the next day. And so that's what we'll do. I'll get the mission management team back together on Monday, and we'll see where we're at that time and whether or not there's enough data and enough reasoning behind an attempt to go fly the Orb 1 launch. And if between now and then it doesn't look like we're going to get to a good option or nothing's coming apparent to us, then we can start moving in that launch window to the right a little bit and deciding to give the team yet some more time. If in the near-term discussions it doesn't look like there's anything that's on the horizon, then we'll look at other options that might have to be considered, including the removal and replacement of that particular valve, which is housed inside a pump module external to the station, and so that will lead us to a series of discussions regarding spacewalks. And we'll have to go down that path. But at this point, we're, for lack of a better term, we're going to kick the can for a little bit and go let the team work a little bit more.
Okay, and I assume there's nothing that the crew is critically waiting on from Cygnus. Obviously, we want to get it launched as soon as we can, but nothing that they need right away.
No, there's nothing there that is somehow or another critical to operations moving forward. We've got our standard set of hardware on there. We've got some a piece of equipment for the EVA suits that when it gets up there we will change that out. But again, that there's not anything in there that I would say is hugely critical to us doing our normal operations.
Okay, so you have the time you need, I guess, to work through all the different options and decide what you need to do, not only with the launch for next week, but also for the fix of the system itself.
At this point, again, I think we're in the early stages of trying to understand it. I think everything that we can do is being done. The system is good and stable. The crew's in good shape. All the right folks on the ground are looking at the problem and trying to assess exactly what the root cause is and what our options are to try to continue moving forward with the flight program. And while we'd like to fly the orbital D1 mission in this window, we're going to do what's right for the program and the crew, and we'll do it safely. And if that means that we can't do the Orb D1 mission while we go sort this out, then that's the right thing to do, and we'll go do it.
Okay. Well, I know this same system, I guess we had a similar issue with back in 2010, I think. Can you talk a little bit about that, how this is the same or different as what we saw then?
Well, when we talk about it in terms of the pump module, it's going to sound the same to everybody. The difference here is that in that particular instance, we had a pump that just shut down. If you look inside the pump module itself, there's several different components in there. In this instance, the problem we're having is with the flow control valve, which is, while it's inside the same housing, it's a separate piece of hardware, has a different controller on it. And so I would say that was a failure to back in 2010, the pump failed, so that was a failure to be able to move the ammonia. What we're having here is a failure to be able to control the temperature of the ammonia. This valve helps us to regulate by saying how much ammonia we're going to pull from the radiator versus how much we're pulling from the normal bypass loop, which is a smaller loop that runs just through the pump and some cold plates and back around again. So it's one that operates at a little higher temperature, and so this valve is basically a mixing valve, if you will. It helps us regulate the temperature. You can modulate it. It modulates automatically based on what the temperature happens to be at that particular time and what we're trying to control it to. And so while it's in the same pump module, it's a different area of the module.
Okay. And well, I know in 2010 we ended up doing a spacewalk to go out and fix it. As you mentioned that's a possibility. We don't know yet that we'll get to that possibility that point. But if we do need to go do a spacewalk, we have the parts on the station that we could use to replace it.
We do. We have spare pump modules on orbit. I think there's no issue with being able to have the hardware to go do it. And in fact, again, this will look a lot like what we did in 2010. It's going out into that same location, and so a lot of the choreography will look the same. Back when we did the pump module change out back then, we didn't have the benefit of the knowledge that we've captured as a result of the last EVA, where we had a problem with the crew member and water in the suit. So we're a lot smarter now, and so there are going to be some things that we'll have to do a little bit differently in preparing for an EVA going forward. Just ensuring that the suit's in a good shape, that we put every mitigation possible in place, and there are a few since that time frame, to ensure that we've got the crew member protected. And so yes, I think we're in good shape moving forward. If we have to go do an EVA, it's just a matter of this time we have to go crank through the plan and let folks go put the plan on paper and go get ready to execute it if we have to go that path.
And I know you're basically just going to take whatever time you need, but do you have any idea what to expect in terms of a time frame when we might know what exactly the issue is?
In terms of exactly what the problem is, this is a tough one because this is not hardware you can get to. It's external to the station, so we can't go open it up, look at the valve, and say, well, it's a seal that's shifted or it's a sensor that's come off or something. That's not going to be obvious to us, and so the team is trying to manipulate this valve and trying to draw some conclusions just based on secondary cues, what the temperature is doing, what the flow rate's doing as they move this valve, and so without putting eyes on valve, it's going to be very tough to get specifically right at it. But this is one of those things whenever we do, if we have to replace it, it'll be on a much grander scale because we'll replace the pump and everything else that's in there that goes along with the flow control valve.
Okay, and you've got time to think about that. There's no looming deadline that you need to make a decision by, or you need to get the loop back up and running for?
In general, we have two loops on station. Our best position to be in is to have both those loops up and running and available to us. And then if while we're sitting at one loop, then I think we're somewhat vulnerable. And so clearly, from a program perspective, our intention would be to try to move sooner rather than later to recover that functionality, unless we have a very good plan and a very good understanding of how to provide that function, should we have an additional failure. And at this point, I don't know that we have that plan. So our intention would be to try to get recovered as quick as reasonably possible, taking into account, the time necessary to get ready to go do an EVA, if that's the path we have to take, or if we have some other options that allow us to stay with the configuration we have, but we just have to operate a little smarter or do it a little differently, allow enough time to let those ideas mature and get potted.
Okay. Well, thanks so much. I think that covers the situation as it is at this point, and we appreciate your time. And you can stay tuned to www.nasa.gov/station for continuing updates on exactly what's going on board the space station and with the crew of the Expedition 38. We'll stop there for now. Thanks again. This was Kenny Todd, the Ops Integration Manager for the International Space Station. This is Mission Control Houston.